and her topic is going to be on biomass conversion technology, industrial analytics. Elmarie, if I can invite you to come in and begin your presentation.
Sorry, guys. Good afternoon, everyone. I'm going to share my screen. Can everyone hear me?
We can, Elmarie.
I'm just going to switch off my camera and then share my screen. I have an introduction on my presentation of myself. So, okay. There we go. Can everyone, is everyone good? Can you see my screen?
We can.
Okay, cool. Okay, so I am Elmarie Diedericks. I will be presenting to you today on industrial analytics on biomass conversion technologies. So let me start up with the presentation and not waste time. As I said, my name is Elmarie Diedericks. I'm currently a technology analyst in engineering at Sasol with the R&T Technology Analysis and IP department. I hold a master's and PhD in coal beneficiation. I started off my career at Proconics as an EIT and joined Sasol in 2021. Starting at technical support and optimization, representing solvents in unit engineer capacity. So I worked at all of the units, and over the past 2 years, I've been working on projects in future technology, ranging from biological CO2 reduction pathways and biofuel feedstock pre-treatment and processing. So my current portfolio includes biomass conversion. So my basic role, or my role at Sasol, is to assist with bridging the gap between technology development, industrial analytics, and assist with the strategic decision making of the company. Okay, so yeah, figure one is me. What you will hear today, first of all, we'll do introduction, and then just discuss a bit on the industrial analytics approach that I'll take. We'll be focusing on the strategic tool called the pestle analysis from biomass to biomass to energy conversion, and then also just a couple of conclusions and references. Okay, so introduction. Carbon is the building block of life, as everyone knows. So it cycles from the atmosphere through the ecosystem and living organisms. The natural carbon cycle exists. However, as we use fossil fuels, it disrupts that natural balance. So if you look, if you have a look at figure 2, let me just get my pointer here. You'll see in figure A or 2A, that's the natural cycle. And then obviously we are now processing a lot of fossils at this stage. So what happens is we disrupt the natural balance because there's a net one-way process. So we are exploiting a lot of the coal that is, or the fossils that is concentrated in the geospheric area, and we are pumping it into the atmosphere and at a higher rate than it can be absorbed by the trees. So that natural cycle is disrupted, right? So alternative energy carriers are important in that regard, based on, you know, the demand increases, and we also have responsibilities towards the environment. So yeah, we need to start looking at alternative energy carriers to meet this demand and to meet our responsibilities to the global, to the environment. So biomass can be used as an energy carrier. It's renewable and versatile. And with the advanced conversion technologies, we can produce biofuels. So bioenergy carriers that can either be liquid, gaseous, or solid forms. However, we can support the decarbonization agenda in that way. However, biomass supply chains are very complex. And the steps require detailed evaluation to determine feasibility and sustainability of the bioenergy production method. Right, so as you can see at the bottom there, biomass has to be harvested. It requires storage, pre-treatment, transport, and conversion. So all of these factors, from harvesting to conversion, also affects the surroundings. Right, so the industrial analytics approach. So before we start, I just wanted to discuss how have you ever wondered how you can transition from a generalist to a specialist? So the first thing that I learned about technology analysis, us being engineers and appreciating detail, was the difference between breadth of information and depth of information or knowledge. So you have a basic choice. As I said, you can either be a generalist or a specialist. Breadth of information, it's wide-ranging. It's a wide-ranging understanding across multiple spectrums of knowledge and skills. This includes versatility, adaptability, innovation, creativity. So it gives you a bit of a holistic view on information, industrial information, anything that's out there. But depth of information, so that's a profound understanding and expertise in a specific domain, right? So it's a deep dive into the nuances and complexities of a specific field. It evaluates the complexities, intricacies of a specific field. So this is generally where the specialist, where our focus is, right? So the analyst's focuses on the depth of information. So we have to summarize the breadth of information and convert it into depth, right? So this is where you gain expertise and authority. We have to have a lot of problem-solving skills. And this is also where you can find yourself having a career advancement. So in between breadth and depth is that transition. So when you have an overload of information, for instance, in the biomass conversion, so we are now at R&D, at research and development, there's an overload of information. We need to support our research in the industry by a firm or a very a framework, So I decided to discuss the analytics approach that I would take today. So there's different ways of doing this. First of all, there's the PESTEL, the P5F, and SWOT analysis. These are strategic tools that we use to assist with decision-making in a business. For instance, now, why would we move into biomass conversion, right? So the PESTEL, for instance, identifies the external factors influencing. So these are the focus on the macro environment. So it's broad. It refers to the larger societal forces, as you can see there. It's system defining factors. It's, for instance, it focuses on the politics, the economy, society, technology, environment, and the legal framework outside. And then in between, you have the meso environment, which is the industry factors, and then the micro environment. right? So that you can achieve with SWOT analysis or P5F analysis. The microenvironment is direct, or it's factors that directly affect the business. For instance, your customers, the suppliers, the intermediaries, and then the direct public. That's what affects the micro. The macro, with the system defining, you usually start investigating the macro environment, and this is where you would have your invention. And after working through all three of these environments, you'll be able to have market uptake of, for instance, this ICTs as intermediate carbon carriers. Okay, so for purposes of this presentation, we'll be focused on the PESTEL. So I'll run through the system defining factors with you guys. So we'll be focused on politics, economic, social, technological, environment, and legal factors affecting a business if we decide to do biomass conversion, right? Okay, so let's continue. Let's start off with politics, right? So we'll jump in. For today's presentation, I grouped legal and political together, just so that we have an idea of, or so that we can, in the interest of time, that we don't waste a lot of time on this. Okay, so regulations and trade. So this is for global, the regulations and trade. Why? How would political and legal factors influence a company's uptake of biomass conversion, right? So you've all heard about the net zero drive. So in the 90s, that started, climate negotiations started, and in the 2000s, it really gained traction. And it became a key goal in the 2015 Paris Agreement, right? So this agreement states that to balance emissions, a balance must be achieved between anthropogenic emissions and removals by sinks of greenhouse gases by 2050, right? So the emissions trading schemes, there's a big drive for carbon pricing, emissions trading schemes, and the European Union is a global leader in this. So they set up the Fit for 55 targets. They want to cut emissions by 2030 by 50% and reach net zero by 2050. Right, so carbon is regulated in various ways worldwide. So as I mentioned, there's the carbon taxes that's enforced in different countries, or the emissions trading schemes, or both, right? So for South Africa, why would we take part in any type of carbon pricing, right? Except for social reasons or ethical reasons. Why would we take part? Some of the countries, as you can see, are not faced with these carbon taxes or with any carbon pricing. But for South Africa, the European Union is a key trade partner, both imports and exports. So we want to keep the trade policy healthy. So that's why South Africa is actually, the government is enforcing carbon tax. And based on that, that's a big driver to move towards biomass, as biomass emits less carbon dioxide, right? So if you have a look at figure 5, a second thing that, or a second factor affecting the political and legal landscape for adopting biomass conversion is economic activity and also risk factors. So if you, just recently we had the America-China, enforcing tax and tariffs on each other. So that had a big influence on the dollar and the yen value, as well as the Russian and the Ukraine war. So the first thing that usually happens, the economic activity is stressed, right? So there's tension there. So the consumption of fossils usually drop, and then investment drops, trade policies suffer. And then right after, because of this, the price would drop. If you can see there on figure 5, prices would drop after an instance like that, because the demand is low. And after that, the price will spike again, because of the supply risk created by this. So there's a drive for alternative energy carriers when the supply and demand is at risk. Yeah, so that's why political and legal factors would drive us to move towards biomass adoption. Okay, so let's zone into South Africa. In South Africa, we have the 2019, or the Carbon Tax Act, that was enforced in 2019. It charges companies for direct CO2 emissions. Currently, it's 194 Rand per ton CO2 emissions. It was a 10% annual increase from 2022. The government has provided some allowances for us to ease the transition to green. Yeah, and South Africa's energy sector is currently still dominated by coal. Coal has high emissions. So if you have a look at figure 6, here you can see the red line, that's South Africa, that's our CO2 emissions. In 2023, we had 400 million tons of carbon dioxide emissions. The Carbon Tax Act kicked in 2019. So since 2019, we've been paying carbon tax. So why is there such a big drive to lower our carbon dioxide emissions? Currently, South Africa is heavily reliant on coal, as I mentioned. Coal is a very big emitter of CO2 gases because of the combustion process. Germany, United Kingdom, Netherlands, the majority of the other countries worldwide is heavily dependent on oil and natural gas. We don't have those reserves, so we have the technology to or convert coal to bioenergy. Coal to to syn fuels, etc. And that emits a lot of CO2, right? So if you focus on figure 4, 2019, we had a high amount of CO2 emissions, so it picked up a bit since 2013. And there was no real drop in the trend. You can see the other countries have drops, or they either have low emissions, or they have a gradient, a drop in CO2 emissions. However, once in 2019, once the carbon tax kicked in, we were dropping, we started paying carbon tax, and as a result of that, we started focusing on emissions, right? In 2022, they revised the carbon tax, and you can see that they projected a new carbon tax price or trend for us. Once the government realized that we are trying to contribute, we are reducing carbon dioxide emissions, you can see that there was a shift in the trend. So that also dropped a bit. So we are entering, or we are approaching the end of the phase 1 for the transition. In phase 2, that starts 2026, there will be some changes to the Carbon Tax Act. So currently the waste sector is not included, Eskom is not included. So a lot of the pressure falls on the private industry. But yeah, as I said, there will be new allowances and higher carbon price paths. So yeah, so there is politically and legally, there's a high drive to convert to biomass, so that we can avoid these carbon taxes, and we can, yeah, emit less into the atmosphere. Okay, so let's continue to the economic factor. Okay, so while CapEx is high, to go green, governments have various incentives for renewable bioenergy initiatives. Incentives is also mentioned in the 2019 Carbon Tax Act for South Africa. You can see that the US and the European Union allocated a lot of funds for that, as well as international finance. In figure 8, you can see that for the least developing countries, this includes South Africa, there has been an immense amount of funding from international countries to support us going green, to alleviate that financial barrier that we have. You know, our economy is set up for fossils. Our infrastructure is set up for fossils. So it is a tall task to convert to biomass. So in terms of market trend, the global biofuels market in 2023 was 180 billion US dollars. That has almost doubled to 2024, right? And it's going to continue to grow with a compounded growth rate, as shown in figure 4. So there is definitely, it shows that consumers are more willing to pay premiums on green products than they have been in the past. So there is no price parity with coal, right? To use biomass. There's no comparison. Fossils is the cheapest. In South Africa, we have huge reserves, and we have timelines left on those reserves that can sustain us for a couple, for a good 50 to 100 years. But it makes economical sense with the government incentives. So this would rather be an ethical discussion than commercial discussion in terms of consumers and their willingness to pay premiums. Okay, so in terms of social, so with the increase in industrialization, countries became developed, and at the rate countries are becoming developed, the food chains becomes more complex. The global population increased by about 400%, and urbanization increased to 43%. And this, along with this, energy consumption increased by 900%. So this leads to a reduction in global reserves, as you can see. Coal has about 134 years left worldwide, and then obviously oil and natural gas. So for us, the majority is the coal. You can see traditional biomass is still low, even in 2024. So that's more in the rural areas that the traditional biomass is being used. However, with this surge in urbanization and population growth, we also have an increase in organic waste production, and the waste needs to be managed. And this waste can it can be used to provide green energy, and in that way also manage the waste. All right. So yeah, about 80% by volume of municipal solid waste. If there's 80% green or organic matter in the municipal solid waste, it is seen as green. So that can be recycled and used. Unfortunately, in South Africa, we have very widespread, dispersed uh, um, waste streams, and they are not properly set up. So we still lack in that. We're also not allowed to use first generation biomass, since that competes with food sources. So we'll only be focusing on second generation feedstocks. Okay. Right, so when we move to the technological area, this factor is where it's most important for us. This is what is what drives essentially innovation and drives strategy, right? So existing energy generation infrastructure in South Africa is set up for fossil fuel processing, as I mentioned. Fossils are homogeneous and fairly pure, so they're condensed energy. So the processing is straightforward. Biomass, on the other hand, is heterogeneous and varies in chemical composition, structure, and impurities are present, and it requires intensive pre-treatment. So that's an additional step to your already to the system. So figure 11 shows you have the different lignocellulosic feedstock selections, or you first have to select a specific feedstock, and then you'll have to pre-treat and also convert. So even if the conversion processes are set up, the pre-treatment lacks commercialization, it lacks progress. So while the lignocellulosic material is abundant, technological challenges remain. So some of them include scalability, production cycles. So they have extended residence times, for instance, in fermentation. They have low efficiencies. And then obviously, as I mentioned, the pre-treatment TRL. So the technology readiness level is a big barrier for us. Yeah, so pre-treatment is generally done to disrupt the biomass. So you essentially want to remove the lignin because that has no real calorific value. It's generally used, it's very difficult to process and to break those carbon chains. So you want the hemicellulose and the cellulose, which is your C5s and 6s. If you've disrupted the biomass and you can remove the lignin, you can continue with the hemicellulose and the cellulose, and you can form sugars, and from that's your baseline. So then you can produce biofuels and products, right? So So the only way that currently makes sense to produce these biofuels or bioproducts, we all know about economies of scale. That's the first thing, and an integration. Generally, an integration or integrated system works better in the technological field. So for instance, if you have a sugar mill, and if you construct a ethanol plant next to it, a lignocellulosic ethanol plant next to it, that would make sense because your feedstock will be there centralized, and you can use that to produce the ethanol. Right, so this is a figure that's actually it's a very familiar figure, I think, to a lot of you guys that dabs in biomass. So you have your feedstock, conversion, then you have the energy carriers, right? So that's your product. So in the majority of applications, the conversion processes, those are set up and they have TRLs. If it can be more than 10, it would be more than 10. Right, so maybe just to, for those of you who don't know, TRL above or well, at 10, you're usually looking at commercial scale plants. 7 to 10, anything below 10 is pre-commercial, and then anything 4 to 7 is pilot and demonstration, and anything less than 4 is research and development. So that's you can only start with commercial if you have a fully developed and functional technological or technical setup or commercial setup. And so that's sorry guys, my time is I'm rambling on a lot. Okay, but anyway, so the biggest issue here is this pre-treatment. So that's not captured anyway, the pre-processing. So preparing any of the lignocellulosic or the second generation feedstocks to go to the conversion process. You'll see that lignocellulosic material specifically is the most versatile. However, currently, a lot of the applications are not commercialized as yet. So sugar and starch crops, those biofuels produced from that is your basic ethanol. So that's the most straightforward biofuel that we have. And it's usually used in blending mandates in countries such as Brazil, USA, where they have those blending mandates. Okay, so, and then just a bit on the environment. First thing is the waste management practices. We talked about that. We discussed that a bit. Currently in South Africa, landfilling is our main waste solution. If we convert 70% of South Africa's lignocellulosic waste, we can meet 24% of South Africa's liquid fuel requirement as bioethanol equivalent. And then just on the other side, the natural resources management. So it's very important if we harvest any lignocellulosic material, or instead of using waste, harvest, trees or any, we have to balance the biodiversity. So we have to regenerate this biomass, and we have to rehabilitate the ecosystems, because those are the systems that capture and sequestrate the carbon in the atmosphere. So it's very important to keep this balance going. So we have to have arid land. You have to consider the rate at which the biomass grows, etc. Okay, and then my final slide, just in conclusion, for South Africa, there's a lot of important opportunities to further deploy bioenergy. But we are largely still dependent on coal as our energy supply. All of our power stations are set up for that. It provides 85% of electricity and 60% of heat currently. Biomass only makes up 3.5%, or it made up 3.5% in 2022. A lot of our local coal is currently exported. And then maybe just something important to look at. Even biomass for charcoal production has halved in the past decade. So there's no notable role in electricity production, and no significant reporting in biofuels and transport. There are opportunities for municipal solid wastes, but as I mentioned, it's dispersed over the country. And we face a lot of delivery challenges that hamper the implementation of using this, accessing this wastes. There has been some implementation for waste to energy systems. However, there's still a lot of work that needs to be done in South Africa to drive biomass conversion. I know most focus is on renewable energies, solar, etc. But there is a big opportunity for us with biomass. Thank you. That's all. Any questions?
Thank you so much, Elmarie. We'll have a Q&A session at the end of the program, so I'm sure that the attendees will be making good use of that. In the interest of time, I'd like to move on to our second speaker. Next up, we've got Dr. Tanya Hughes. She's a Capacity Development Manager R&T at Sasol. She's going to give us an overview of Sasol, and I'm sure that a lot of the postgraduate students that are on the line will be quite interested in this one. Over to you, Tanya. Thank you so much.
Thank you, Prof, and thank you for the opportunity to do this. I think I've been here now a couple of years, so if you've gone through this journey with us, you would know who I am and also what I'm going to present. So I'm going to quickly give you an overview of who we are as Sasol, what programs we have. Some of the postgraduates online are already part Sasolite, so they're already part of the team. But I quickly want to just, again, refresh your minds who we are, what we do, and as Elmarie said, how we're going into the future, looking at our sustainability and also where we are with regard to environment, etc., etc. So firstly, my name is Dr. Tanya Hughes, technology at Sasol. I am a scientist, so probably the only scientist in the room with a PhD in organic chemistry. So any engineering questions will be directed to Elmarie. And then I'm going to give you a quick overview of who we are. So firstly, this is a little video. Just let me know if you cannot hear the sound as soon as I start.
In the heart of South Africa lies an incredible story of transformation and impact. A story where innovation becomes the driving force for progress. At Sasol, our talented people harness the power of science to shape a better world. From our cutting-edge research facilities to our expansive production plants, our journey is driven by a pioneering spirit. Every breakthrough we achieve unlocks new opportunities to fuel progress and enrich lives. Our innovations bring essential products that touch our daily lives, fueling vehicles, powering aircraft, heating homes, and enhancing everyday convenience through household essentials. But the impact doesn't stop there. Through innovation, we empower farmers to grow the food that nourishes us, enable the mining of minerals that build our world, and energize industries to create jobs and opportunities for a brighter tomorrow. For 75 years, Sasol has been more than an energy and chemicals company. We are a catalyst for positive change, advancing socio-economic development and driving sustainable progress. At Sasol, we are committed to transforming science into solutions that uplift lives, support livelihoods, and build a modern world. Sasol, innovating for a better world.
Sorry, I think that is quite a nice, almost Lion King-like video. It fills you with so much pride when you watch it. So that gives you a bit of an overview of who we are, where we come from, and how far we've come. The next slide just shows that we, as a company, and we are looking at a future moving with South Africa. I know a lot of you might have looked at the news and see that we are expanding into the rest of the world, but our hearts remain in South Africa, our roots remain in South Africa, and that is why everything we do, as Elmarie has also discussed, going from a more coal-focused company to going into biomass, looking at other alternatives, it's with an absolute focus of building capacity and building the country. This is a little bit of a view of a snapshot of how we intend to do this and how we look at it. And also another snapshot of how where we operate, how the business has grown over the last 75 years, that we are now located in 22 countries, of which the main country still remains within South Africa. We are expanding and we are growing, and we've got little stakes in like EGTL, which is hosted or based in Nigeria, also in Uzbekistan, as well as in China, and then in America and the rest of Europe, our chemicals portfolio is mostly focused. So we have about 27,000 employees around the world at this point, with the largest contingency of that existing in South Africa, because we've got the largest plants that still remains within South Africa. So I'm not going to go into too much detail. We are also signed into the Sustainable Development Goals of the United Nations. And within this, we focus on some goals that are relevant for Sasol, as well as for the bigger South Africa as well. So quickly going into a little bit of a deep dive about what we do. Elmarie has also touched this. So we basically take coal and natural gas. We put that through a gasification process to make synthesis gas, and then based on our proprietary Fischer-Tropsch processes, we then make a whole host of products. So most of you would hopefully have seen one or two Sasol fuel stations around your area, but I think a lot of people miss that Sasol does not just make petrol and diesel. We also make the starting materials, or the base materials, or the monomers, if you want to call it that, for a whole host of products, as you can see at the bottom of the screen. So if you're wearing perfume today, you're probably wearing something that was a Sasol product was added to. If you have some blush on your face, the ladies, you would also have used a product that has a Sasol base product in it, as well as painting or lubricants, plastics, etc., etc. The list goes on and on. I always, when I present this to some of our younger students, they are very surprised that almost or most of the things you use in and outside of your house contains Sasol byproducts or Sasol products. So in the interest of time, I'm just skipping through this, focusing a little bit on our R&T, or research and technology mandate. We are the custodians for science and postgraduate chemical engineering pipelines within the Sasol company and the larger Sasol company. We have our main operations within Sasolburg, with also smaller fraternities in Secunda as well as in the Netherlands. And then we have some applications research that focuses on the energy landscape. We even have our engine testing facility in Cape Town. Everybody wants to go work there, but unfortunately, that's a very small part of our business. So we are highly disappointed that we cannot all go and work in Cape Town, or even here in Durban, where some of the refinery or some of our customers are as well. Then and we've got a base chemicals that is situated in Modderfontein, and then performance chemicals in Germany, Italy, China, as well as in the USA. Little bit of how we collaborate. So we've got different funnels of collaboration, if you want to call it that. We've got our mainstream bursars that I think Amanda is online under Prof. Lockhart. That is actually one of our postgraduate bursars, our mainstream bursars. And these bursars have a work-back obligation contract with Sasol, and after the completion of their bursaries, they come and work for us. They then go through a graduate development program, after which they are then appointed as scientists or engineers within the company. We then also have a lot of subject matter experts that goes around the country, as well as in Mozambique, and gives lectures on heterogeneous and homogeneous catalysis, as well as some of the refinery stuff we do, as well as our chemicals portfolio that especially in UJ, we have some lecturers that lecture there as well. We then have industry academic engagements, where we have partnered with the NRF to host a number of projects that we fund through the NRF or along with the NRF that focuses on the energy or the changing energy landscape within South Africa, that has a little bit of a Sasol flair or a Sasol theme that we can then gain information from, but it's mostly to build capacity within the South African context. And then we also do dedicated research with some of our South African universities, where we have a problem, and then we approach them and they do some research for us as well. So not going to go into this slide. I think the main thing, as Elmarie has also shown, is that as Sasol, we cannot change the energy landscape by ourselves. We cannot change any of the science or engineering questions or problems that is out there by ourselves. We need to collaborate, and not just within different universities or different industries, but also within different disciplines. I think for a long time, Sasol has been quite successful in collaborating with science or merging science and engineering, but we also need to look at our social sciences, look a little bit at our humanities to make sure that in this changing landscape, we do not leave anyone behind. As Elmarie mentioned, South Africa is quite still our coal mines and our coal miners and everything that surrounds that is quite important to our socioeconomic development and our economy. So shutting down a whole coal mine would be detrimental to our socioeconomics as well as to our economical environment. So it's very, very important for us to work together and to, merge all of these different disciplines so that we change the energy landscape systematically, but also make sure that no one is left behind. Lastly, and I think this is what will be most interesting for most of you, these are the bursaries that we have historically and up to now have funded or awarded. And it's only in the engineering field where we focus on a B-Eng in chemical engineering, civil engineering, mechanical engineering, as well as industrial engineering. And a big part of electrical engineering is also becoming more and more important. In our science fraternity, our focus is on chemistry, geology, and data science. But these fields will branch out as the landscape changes. So please do keep an eye on our sasolbursaries.com website. Unfortunately, the call for bursary applications for next year has closed, but the call will again open around May for the following year, and you can apply for a Sasol bursary regardless of which year of your study you are in. So if you are in your first year of master's, you can apply for your second year of master's. If you are in first or second year of PhD, you can even apply to be funded for your final year of PhD. And if you are successful, you will still have the work back obligation on the discipline or on your theme, but that is not a deal breaker. So please do apply. Do not think that you are too late in your studies to apply for a Sasol bursary, just with the understanding that you'll have to, if you are successful and you do get a Sasol bursary, that you'll have to move away from the beautiful view you have here and come and look at the mining dumps that looks like mountains in the middle of the country. So just be aware of that. Then a little bit of what the career landscape looks like for a scientist or engineer. You will start off as an engineer or scientist in training, and from there on you'll move into R&T. As a rule, has been almost the feeding ground for all of the different careers within Sasol, also into other companies. So our engineers and scientists are really, really trained well, and they are sought after, not just within South Africa, but also within Europe and America even. So starting your career at Sasol is never, you will never be sorry starting a career in Sasol. And we always joke and say, if you have a bursary from Sasol, you always go in and you say, I'm only going to work back my bursary obligation and then I'm gone. And being a bursar as well, I had the same frame of mind, and now 14 years later, I'm still at Sasol. And we tend to stick and we tend to stay because it is quite an amazing company to work for. So that is me, and I'm going to end off. Thank you, Prof. Lockhart. Thank you for the opportunity. And I think we'll go over to questions now.
Thank you so much, Tanya. Elmarie, we really enjoyed those presentations. I think you've given us a little bit of a snapshot of what you are doing at Sasol and the future things to come. I can open it up for some questions from the participants and the audience. Please feel free to put your hand up. You can ask your question directly. If you want to, you can put the question into the chat box. Tanya, I know that you need to drop off quite soon, so hopefully you can get a chance to take some of the questions as well. Kabile, if you are
If
still
there's no
online,
questions, we did our jobs well.
I know. Yeah, and I do believe that some of the attendees today have connected into previous tech talks, so they're well aware of the program.
And Prof, if there's any questions that someone is too shy to ask here, I'm welcome to direct it to me afterwards.
All right, I'll do that. I can confirm that I'm not seeing any hands on the participant list, and I'm not seeing any questions in the chat box. In that case, I'd like to, on behalf of the college, oh, there we go. There's a question. Oh, sorry. It's a question that's come directly to me. So I'll just read this out because you can't probably see it on your end. If we move to renewables, will this not disadvantage us given that we do not contribute anything to the renewable supply chain? That's an interesting one. Maybe a question for Elmarie to take.
Just please rephrase. Sorry.
Okay, so the question, Emmanuel, if it's possible, if you can come in on the line and maybe you can elaborate on your question. Are you still there? Are you able to do so? There we go, something here. Okay, maybe let me take this question with Tanya. If you start your career at Sasol, sorry, oh, is that you, Emmanuel?
Yes, I was having problems with connectivity, so I'm now using just this.
That's fine. Go ahead with your question.
So my question is, given that we have a lot of coal, which is very cheap and in turn increases our competitive advantage in, say, production, will moving to non-renewables not disadvantage South Africa as a country, given that I assume we contribute very little to the overall supply chain. We do not make solar panels, we do not make batteries. Economically, is that not going to disadvantage us in the bigger frame of things?
So, as I understand it from research and the statistics, it's not that we don't contribute. We do have, I mean, a growing renewable energy portfolio or sector in South Africa. However, it will, for us as a country, it's going to take some time to transition to bioenergy specifically. So there's a bit of there's a difference between biomass processing and your renewables. So currently we largely non-renewable. So we want the biomass, if we consider processing that, to mimic the characteristics of typical fossils and what our infrastructure is set up for. But it won't be, in my view, it should not affect us in the bigger scheme of things. So there's options. You can collaborate with, let's say, mines. The carbon pricing is set up in a way that it does support transitioning. So in the end, we will be supported. It's just the focus on our intermediates needs to shift. So yeah, so it won't put us back. I mean, government should just, they are enforcing, they are taking big steps. And at this stage in the transition area or era, it is going to be difficult. But I mean, worldwide, there's been a lot of progress. Yeah.
Hey, colleagues, please take note. The gas alarm activated at NB.
Apologize for that, Elmarie. There seems to be an announcement somewhere. Okay, thank you so much for that answer. I saw a couple of other questions in the chat, but Tanya's just managed to address that. And I believe she needs to drop off quite soon. And there is another question perhaps for Tanya here. The presentation only mentioned data science. On the data side, is there data engineering involved?
I was busy typing away ferociously, but I can quickly answer that. So currently we are focusing on the data science, and our chemical engineers go for a in-class data engineering course. So it's more of a taking our current engineers and then evolving them into the data engineering world. But that does not bar us looking for specific data engineers in the future. So as I said, at the moment, we are almost like reskilling our current ChemEng to the data engineering world. But in future, Nosipho, we would probably look at data engineering by itself. So keep your eyes open for that.
Thank you so much, Tanya.
Okay, I am going to go off now, Prof. Lockhart. Thank you so much again for the
Thank you
opportunity.
so much.
If there are any questions, please direct them to me, and then I will answer them individually as well. Okay.
I'll do so.
Thank
Thanks
you,
so much.
everyone.
All right. I'm not seeing any further hands. And oh, thank you, Elmarie. There was an announcement on your side. Okay. I thought it was happening here at the university. Okay. All right, and then if I can then close on that point, I want to then thank again our speakers. Tanya's just dropped off, but thank you, Dr. Diedericks. It was very informative. We had a good overview of what the future holds with regards to the use of biomass and fossils in the country. And we really do appreciate the time that you've taken to present today at the Sasol Tech Talk. Thank you to the attendees as well. I hope you enjoyed the presentations, and please feel free to connect with the college and myself, and we'll be able to address any further questions that you may have on the presentation. Thank you again, Elmarie. Have a good day further, everyone. Goodbye.
Thanks, everyone. Bye.
Thank you, bye.